All right, so let's talk extrapolation. Nick, go on then, what would you say?
It's like when you can infer where it might be because of the data that's already there.
Say it again, sorry?
When you can infer like where a point might be because, or you can infer something about the data because of the existing data.
Okay, I wouldn't say if that's what I was told, I wouldn't necessarily get it, but I know what you mean. Greg?
It's kind of hard to articulate, but like extrapolation is like making a prediction past a set of data, assuming that the trends in the data continue.
Okay. Here, what were you going to say? No, go for it.
I was going to say that extrapolation is an estimate or a prediction by looking at the data that's on the graph.
Okay, but is interpolation the same thing then?
Kinda.
Interpolation is when is predicting a value, predicting a value on the graph between two already existing points.
Okay.
While extrapolation is done by extending the data.
Okay, so let's get one thing clear then. They're both making predictions on the data. Okay. Extrapolation is outside of the data set, just to keep it simple, and interpolation is within.
So is interpolation just like the word for prediction in Latin or something?
Probably.
Yeah.
So basically, yeah, if we were to look at our line of best fit, so what did we say about line of best fit? Had to go through. So let's put a mean point about there, and let's say my line of best fit went through something like that. Okay. I think that's too bad. All right. Yeah, oh yeah, that's not too bad. I might be completely wrong. How do I do a correct line of best fit? Yeah, least squares regression analysis. You know that the computer will do that for you. We'll find the equation of the line. Let's say this equation comes out at y equals 0.23x plus 14.9. Just made it up, top of my head, all right? So that's the equation of the line that I've thought. So, yeah, so a computer would do the least squares. You can do it by hand. Obviously, people used to have to do it by hand. You're never going to have to, right? Not with me anyway. But that's what can happen. I mean, it's not hard to understand, really. What you do is you know the coordinates of the point. You then just look at how to get to the line, work out the area of a square, and add them all up. And then you have to kind of change the line and work it out. But obviously you can do more mathematically than that to minimise things. But with a computer, it's nice and quick and easy. All right, so the thing about interpolation then, if I were to make a prediction between these 2 points here on the line, okay, so between this x min and x max, anywhere in here, I can make an interpolation, okay, because I am predicting within the data set. So there are values around that give me guidance. Anything beyond, well, I don't have much beyond here, but anything beyond either way will be extrapolation. Okay. Now, what's important about knowing whether you are interpolating or extrapolating, do you think?
When you're making an extrapolation, you're making the assumption that the pattern continues.
Yes. Nathan?
In interpolation,
Yes, why? Because
you already know that that's for sure like a trend. You have to use like.
yeah, that was very dramatic. Yes, as Tatum said, if we interpolate, we know the data's there. We can make a judgment on data we know has happened. And as she said, and as Greg said, if I were to try and predict, so remember what we were talking about before, if I try and predict a value and I go up to the line, that's how we do it, yeah?
Yeah.
And then we read across, and this up here is my prediction. How good is that going to be? Okay. Well, that's it. We don't know. It could be great. It might not be. So what is the word that can go with that and when we think about criterion D stuff? What are we doing? What must be? So we're talking...
Degree of accuracy?
Maybe degree of accuracy is a bit different because that's how many decimal places or how close to an exact answer. We don't know, but we are...
Assumption?
We are assuming something. What are the other words we've got in our criterion? Justification, yeah. We'd have to be able to justify, right? We are talking limitations. We are having to verify. Okay, so I can't just extrapolate because there may be issues. All right? So, for instance, very topical. Okay, let's talk about what would happen if we were to plot age against cross-country times. So what would you expect the graph to look like?
Parabola? Or no, not parabola. Quadratic.
Almost no relation. Almost.
So do you think as we've got age here, yeah, and we've got cross-country times.
In this race or just overall?
Let's just, because it's topical, but let's just think about it in general. Any race, this race, whatever you like.
Any race,
Wait,
okay.
but times that means the higher the worse.
Yeah.
So it's gonna be like.
Yeah, a U-shape.
Okay, so are we going to have the youngest student being relatively slow? Yeah. Obviously, there's going to be lots more data. Probably would have been a good one to go out there and record today. We can still do that. And as we get older, they get quicker. Yeah. So what we would then go is, right, let's make a prediction. Well, what's wrong with our prediction?
Well, number one, it doesn't show. If you only have half of the data, you would and you were like an alien, and you didn't know that old people got slower. You would assume that the older you got, the faster you got, and also you can never have a negative cross-country time.
Okay, so let's say this is 18 years old and this is 11 years old, all right, for you guys running outside. And we've got that. So we make a prediction. We say as people get older, they get faster, all right? And we're trying to make a prediction on that. So as we can put a line of best fit in, okay? But what we're talking about is we're talking about validation here. And we're kind of, can you validate any conclusions? But actually, what is the problem here? Well, you've already said, haven't you? As we get older, we get a bit quicker, but probably from 18, it probably starts leveling out, right?
Yeah, and then goes.
I would say like the tip point would probably be at like 28.
Depends.
It does depend on.
I would say, yeah.
Yeah, if you
I would
train.
say
But you're right. I mean, actually, I would. Looking at you guys outside, I'd go with once you hit M5, it all goes wrong because you know they're all really slow.
I think M3 is probably like M2 I used to be fast.
But I mean, they're constant all the time. Remember Quincy using them for 5G.
Yeah. But that's because he did it outside of.
Yeah, I feel like if you train, you can like.
Yeah, I mean, there's a lot of other things, and also, but it would definitely, wouldn't it, as we start getting even into, let's say, 30s and 40s and things, we would start to get slower until we hit maybe 60. I mean, you know, we've got an example out there today of someone who was still running and beat a lot of these 11-year-olds, didn't they, including M5s and things. So actually, we should, out there today, we should have some ones up here, shouldn't we? Yeah. So we have, this is not a linear relationship, however, up to a point. So maybe up to, in this region, maybe we can say we've got a linear relationship. All right? But after that point, something else happens. And this is where we have to think about how good is our model, how good are our predictions. And this is the problem. Would there be any issue with interpolation? Can I predict what time you're going to get?
From the yellow section?
From the yellow section.
Yes.
We're happy with that.
Yes.
But can I extrapolate? Probably not. Not with that linear model. So that's the difference between those
you could,
two.
but it wouldn't be accurate.
Yeah, okay. All right, so we've got a few things to make sure you've got full notes written down now. All right, so what we've got for you to consider, all right, so some of it might be easy. You need to make sure you've got notes. So I'm just going to go through a quick, not writing those notes for you. You can get the textbooks out in a second, you can do it. But basically, we've got to talk about what was one of the first things. So I'm going to assume you can plot a scatter plot. What was one of the first things we had to get right?
The mean.
That wasn't the first thing, actually.
The X and Y axis.
Okay, and what's the deal with the X and Y axis?
The Y axis has to be dependent on the X axis.
Okay, so we're talking independent, okay, and dependent variable, and the axis that it goes on. Okay, so you've got to make sure you understand and know about that. Okay, we've got plotting points and we've got a line of best fit, even if it's by eye now. So by eye is just where you lay your ruler down and draw it, but it must go through.
Mean point.
Yeah, must go through. If I put this, are you happy with that as the mean point?
Yeah.
Actually, we should mention about correlation, yeah? That was actually the first thing we looked at. And we had, what are the words? We must consider
The direction, the strength.
form, direction, and strength. Yeah. Do you remember what form was? Whether it's linear or not linear. And direction?
Positive or
Positive
negative.
and negative. Why have I written direction twice?
Oh, strength.
Strength we still need to talk about, actually. We've got a mathematical process for strength. We've got correlation. Is there anything about strength, by the way, that links into line of best fit? Nick?
The least squares.
Not yet. Not yet. Yeah, so we can ask the question, do we always draw a line of best fit? And the answer, as Kieran said, is
No.
no. If you do a line of best fit and there's no correlation, your line of best fit is useless. All right, it has no use and it could go anywhere, any direction. All right, and it's just you don't make predictions when. Yeah.
I don't know if this is what you meant by. No, I'll just.
Karen, go on.
So, could you actually mathematically determine the strength with the line of best fit?
Actually, we kind of use it.
Yeah,
It's not using the line of best fit, but it's using a very similar process.
like if the.
We have something called the Pearson's correlation coefficient.
Is that the thing, like last class, it said like you take 2 points and then, no? No, never mind.
It's similar to kind of the idea of doing least squares regression analysis. You kind of do that process and you're along the same sort of lines. We're looking at the distance of all the points from, and obviously if points are far away from their line of best fit, the correlation is weaker. Okay, so that's what we're looking at. So do we always draw a line of best fit? And then we've got how good is a prediction. Okay, so we've just been talking about that. So if you can, using any diagrams, whatever you want, make a decent set of notes now in your textbook, not in your textbook, in your exercise book, to make sure you've got all those things covered. All right. The reason why I say that is because when you have an assessment on this, probably the assessment on this will be, let's go out, collect some data, do some analysis on the data, you write what you find. And I would expect you to understand, well, the correlation is this is what it means. I can use this to make predictions, or I can't use this to make predictions, and why can't I? My prediction is a quality prediction. I'm going to verify that doing this. The validation of it, I'm interpolating, am I extrapolating, that kind of thing. If I am going to extrapolate, am I sure that my data will follow this pattern or not? These are the kind of things you're going to write about. So at this stage, making these notes, make sure that you've got all of that covered. Does that make sense? If you want to get textbooks out to add any notes and things, you can. Do that. But I figure we've done a lot of talking for the last few lessons without writing a lot. So let's make sure you've got this in your notes. All right, so one more word to consider, and it goes with this: how good is a prediction? Okay, so what have we got so far for how good is a prediction?
As accurate as
Say it in.
yeah, it's as accurate as the correlation between two variables.
Yeah. Okay. Right. Does that mean that if you have a really strong correlation, that your prediction is still definitely a good one?
Not definitely.
Okay. Well, it depends if it's interpolation or extrapolation.
Yeah.
Okay. And there is another word we do need to consider. Okay. Which is causality.
Oh, Tebow called it. Wow.
Well, I did already put it on the board a couple of lessons ago. I said, okay.
Oh yeah, 4 phrases.
Any idea what causality or causation might be?
Maybe like if something happens to one variable, it happens to the other one.
Well, it's along those lines, not enough detail in it.
So, like, what specifically about the x variable is making the y variable change? So, like, with the there's one here that says the temperature and the heating bill. As the temperature decreases, the heating bill increases. So maybe you could say the causation would be the family needing to raise the heating back to normal.
Okay, so along those sort of lines. So what we've got, Ethan?
Wouldn't that also be able to work the other way? If it's like if the temperatures were warm, the thermostat or the cooler, the AC would be on.
Was on more, yeah. But what we're talking about is there might be a very strong correlation between two variables. Nicholas, what are you doing? Okay, pay attention. There might be a very strong relationship, apparently, between two variables, but...
you could just be confusing causation with correlation, or correlation with causation, because just because two things have a very strong correlation, it could just be, that doesn't mean that one is necessarily causing the other.
Okay, so it's along those lines. So, causality means, yeah, you're looking for a relationship between two variables. However, there might be something in the middle, okay? So yes, if you look at one variable changing and it appears there is a relationship and it makes a changing another, but actually there is no direct relationship between the two of them. Okay? So the temperature goes up and my electricity bill in the house goes up.
There's something in between. It's not just a natural.
So is the causation the temperature that makes my bill go up?
No, it's you feeling hot because of the temperature or
cold
because of the temperature, and then you turning that.
Okay, so that's more it, isn't it?
Yeah.
So if I actually think about what does cause what, so me feeling hot causes me to switch the air conditioning on for longer,
Yeah.
and the hours of air conditioning running causes my electricity bill to be higher. But if I skip the middle and just say temperature and bill, it makes sense. There seems to be a correlation, but it's not necessarily that is what causes it. There's another cause there.
Yeah.
All right. So when we consider causalities, there's something that's another thing for you to consider. You can't say straight away that affects that. You've got to think, well, does that affect something else that affects that? Yeah.
So like another example for the graph we saw earlier, your score in the test has a correlation with the amount of revision. It's not just okay. Naturally, it's really just you revising causes you to know the material better, which causes you to have a better understanding and know the answers to more questions, which then causes you to have a better grade. It's not just
yes.
Yeah.
Okay. So we've got to be careful when we look about it. So if you look on page 128, it does say about interpreting correlation. It's not just as simple as there is a strong correlation and that's it.
So basically saying causality and correlation isn't just
Potentially. So you've got to be careful that when you go out, if you do a project, which you will, and you collect some data, you've got to think, is actually what I'm collecting in my two variables, is there a direct link? Or actually, is there something else in between, okay, that has the bigger effect? So if we go back to the running and the age thing, is getting older the cause of me getting faster? Exactly. So you might kind of go, well, actually, to start with, as I get older, I've done more training, my body, that causes me to get faster. And then actually, as I get even further into my old age, my health deteriorates, and that's what causes. So actually, there are other factors, and that's kind of where something you can discuss. So this is a great topic for you to get in those 7s and 8s, the verification, the validation, the justification, all that kind of thing. Okay?
Yeah.
I'm staring at you now, Liam. It's like, ooh, okay? So make sure you've got that and write it down. 2 minutes before we go. Make sure you've included that in your notes.